Welcome to section 2.5, day 1, derivatives of trig functions. Today's objective is to determine the derivatives of trigonometric functions. So here's a table of our trig derivatives. We have talked about a couple of these before, and if you took and you have sine of x, we've seen this before where if you took the derivative of this, you would get cosine x. If you take the derivative of cosine x, you get negative sine x. When you take tangent x, you get secant squared x. Cotangent x is negative cosecant squared x. And then secant x, when you take the derivative, is secant x tangent x. And when you take the derivative of cosecant x, you get negative cosecant x cotangent x. Once we know the derivative of sine x and the derivative of cosine x, the other four can actually be derived by using our quotient rules for finding derivatives. You will need to know all 6 of these, so I strongly recommend you put these on note cards and learn them because you need to know all 6 of these. So here we have a couple of functions. It says find the derivative of y with respect to x. And we have y equals sine x plus 5x minus 14. So we take the derivative, dy dx. From the last slide, the sine of x, when you take the derivative, is cosine x. The derivative of 5x is just 5. And the derivative of negative 14 is 0. So this is my derivative of sine of x plus 5x minus 14. The next one we have is y equals secant x tangent x. And we're dividing, so let's use our quotient rule because we need some practice with this. So to take our derivative, we take dy dx, use our quotient rule, and we have low, which is tangent x, derivative of the high, which is secant x tangent x, minus high, secant x, d low, secant squared x, all over low squared. We can then combine and do some work with this. We have a tangent x and a tangent x. We have tangent squared x. So we have tangent squared x and secant x minus secant cubed x all over tangent squared x. And we can leave it like this. So the derivative of secant x over tangent x is tangent squared x secant x minus secant cubed x all over tangent squared x. So when we do these derivatives, you will have to use your quotient rules for some of these. So you'll want some practice with that. Here we have 2 more functions. It says find the derivative of y with respect to x, and we have y equals 5x cosine x. For this one, we need to use the product rule because we have a function here, 5x, with the variable in it times cosine x. So we need to use our product rule. So dy dx is the first times the derivative of the second, which is negative sine x, plus the second times the derivative of the first. And then we will make this look a little nicer. We'll have negative 5x sine x plus 5 cosine x. And that is our derivative of 5x cosine x. Using our product rule, we get negative 5x sine x plus 5 cosine x. And the next one we have is y equals x over 1 plus sine of x. And again, we will have to use our quotient rule. So dy dx equals the low, which is 1 plus sine of x, times the derivative of the high, so low d high, which is just 1, minus high, d low. Derivative of 1 is 0. The derivative of sine x is cosine x. All over low squared. We are then going to make this look a little better by simplifying a little bit. Because 1 times 1 plus sine x is just 1 plus sine x. And then we subtract x cosine x. And it's all over 1 plus sine x squared. Make sure you keep this in parentheses because the whole thing is squared unless you want to expand it out. And this is my derivative of x over 1 plus sine x using our quotient rule. So here it says find y double prime if y equals cotangent x. Well, when you take the first derivative of cotangent x, y prime is negative cosecant squared x. Now we need to take the second derivative. I'm going to rewrite y prime as negative cosecant x cosecant x. Because cosecant squared x is just cosecant x times cosecant x. So I'm going to expand it out so we can use our product rule. So we do y double prime. We have our negative in front, so our first times the derivative of the second. And our derivative of cosecant x is negative cosecant x cotangent x. And this is going to be plus the second times the derivative of the first. Now we have a minus, and then we have minus cosecant x cotangent x. If you do a minus in front of the cosecant x, we've got to bring that with. So we have a minus minus. So of course the minus minus will become a plus. But let's make this look a little better. We have negative cosecant x times negative cosecant x. So we get cosecant squared x. We have a negative times negative, so it becomes positive. And we have a cotangent x. Then we have cosecant x. This becomes a negative negative. Cosecant x is positive. So we have another cosecant squared x. And then we multiply we have the cotangent x here comes along with. So now we have y double prime is cosecant squared x cotangent x plus cosecant squared x cotangent x. And if you notice, these two terms are exactly the same, so we can combine them, and we have 2 cosecant squared x's cotangent x. This is my y double prime, my second derivative of cotangent x. Next chapter, we will learn something that will make this second derivative a little bit easier by using something called the chain rule. We will do that in chapter 3, but for now you have to actually expand it out and use your product rule. So that is section 2.5 day 1, where we're using the derivatives of our trig functions. You do need to know your derivatives of your trig functions. One thing that's nice, if you know the derivatives of sine of x and cosine of x, you can actually derive the rest of them, but you really want to know all of them, so you do not waste time having to derive the derivatives of tangent x, cotangent x, secant of x, and cosecant x. Because when you're doing some of this stuff, you do not want to have to take that extra time to do all the work that's required. So try to memorize all of these. You will need to know them. We will use them extensively throughout the year. Thank you for watching, and have a nice day.